this webinar. Network Instruments has been a partner of Open Realities for almost 20 years now, and for all of that time we've been specialists in networking and application performance management. That's about the end of the sales piece. If you've got questions, do please feel free to ask. As Carlos said on the chat, I'm here to answer any questions that you may pass, as is James. So James, thank you. Over to you, please.
Okay, hello everyone. So I'm going to try and make this as pragmatic, as practical as I can. I've got 6 questions which I think are good questions to ask in terms of application performance management from a network perspective. So my first question is going to be just to understand how the application's actually communicating over the network. Then we're going to go into looking at response times and the different ways in which we break response time down and track that at different levels within our solutions. When a response time is not looking normal or is exceeding a threshold that you may want to set for judging that things are degrading and potentially impacting your end users, you need to understand where that deviation is occurring on the network and who's affected, and then you need to be potentially notified automatically, ideally, so that you can be proactive, so that you're getting ahead of the game. Then you need to be able to look into the root cause of those deviations, be able to drill down, and we'll look into that, as well as finally rounding off with looking about more from a planning perspective. How can I look at potential new deployments of applications and how they will impact the network? So then we'll finish with a review and with a question and answer session. So my first question is, how are my applications communicating? And this is where I will depart from PowerPoint and go into what you can see in front of your screen now is a web interface. This is a reporting platform called Observer Apex, and what this is doing is this is taking data from data sources which are looking at packets. So this is all coming off the network from either a tap or a span port into an appliance or a software solution. We generally call them probes. They can also be Gigastores, which I'll talk about later. But that data is then being processed and analyzed, and statistics are being stored. And those statistics include information about what conversations are occurring, what servers talk to each other and talk to the clients for your applications. So if you want to then discover that, you can go into this view here, which is called an application dependency map. So what I'm going to do here is I'm going to discover some servers, and I'm interested in my email application, my email services. So I'm just going to put a little filter in here on application SMTP, as you can see there, and I've got a particular time range. And now this has brought me back a list of 3 SMTP servers. I'm just going to choose one of them for now. And that now puts this on my screen here. I'm just going to pop it into the middle of my view. So from this view, I can build up a diagram, a map of the connections to this server. I can click Discover Connections. I want to look at both clients and servers. So I'm going to specify either. Again, I've got my time range. Again, I can filter by application or by IP. I'm going to choose to roll up clients, so I just get one icon for all the clients that connect. So now I get a list of the connections to that server that have been observed passively, as I said earlier, from the network traffic. And here I'm going to choose HTTPS. These are the actual clients connecting to this mail server. So that's represented those with this icon. I'd quite like to have those at the bottom of my diagram here, so I'm just going to drag that down. And now I'm going to do another discovery. I've rolled up the clients, but I want to show the back-end servers individually. So I'm not going to roll up this time. I'm just going to choose OK, and now I'm going to add on the POP3 and the SMTP. So in a couple of clicks, really, I'm building up a picture of the clients connecting to my email server, and then some back-end email traffic, both SMTP and POP3 traffic to another node on the network. There's other things I can do here. I can go in and change the icons, rename things, but you can see here how I can use this process to interactively build up a picture. A picture tells 1,000 words, if it is a famous old saying. So it's a great way of seeing how do those connections look. It's obviously more intuitive than seeing things on a long list or in a less pictorial format. That was the first piece of this, and you can think of this really as being at a fairly macro level. We could be looking at quite a long time range here to see data, possibly over many hours, days, or even weeks, in order to see all the different communications that are occurring over quite a long time period. What I'm going to do is show a more kind of micro perspective, if you like. This is using Observer, and what I've got here is some traffic that I've captured. So perhaps this was traffic at a particular point on the network where we're seeing a number of client locations, client connections into various servers. Again, I'm just asking the questions, how are my applications communicating? But at a micro level, I've got all these conversations here. These are all the individual threads that I'm seeing over a particular time period in this view here, which is part of the expert analysis of Observer. So Observer is this software application, and I'm looking at these connections, and I've just highlighted 3 different connections because these are actually happening at pretty much the same time, and they seem to be associated with a particular pattern of activity that I was looking at, connecting to some web services. So when connecting to these web services, I can see there's some HTTPS data. There's also some Kerberos and some LDAP, and that's the actual back-end authentication and the directory access information in order to connect to the correct services. So one of the things I can do in here is this connection dynamics view, and what this does is gives me this very useful ladder diagram of these interactions. So again, this is at the micro level. This is looking at the individual packets as they progress. You can see these LDAP search requests and responses, and I can really see how that pans out over time in order to understand in detail what happens when my applications communicate and when a particular client connects to a particular web server. So that's just starting with those 2 things. Let's go back to the slide. The next question I'm going to look at is what are the normal levels of response time? So let's go back into this web reporting interface and let's have a look at another type of view that we can have here. So what you see on your screens now are these 6 green boxes, and these are traffic light indicators. These are looking at client, network, and server response time for a multi-tiered application which involves a web front end and back-end database traffic. So that's what the 2 rows represent, the 2 components of this application service that's being delivered over the network. And this is really all about that service delivery element and how you can monitor that effectively. So we're using these dashboard components to compare these response times with baselines. I'll talk a little bit more later on about how we can set various types of threshold sensitivity based on these baselines. But for now, what I'll say is that the baseline data is basically looking at a number of time periods previously. And we can compare those time periods in a few different ways. For example, I may be comparing a particular day with the previous 3 or 4 days in order to look at a typical daily metric or usage parameter. or I may be comparing with maybe the same day on each of the 3 previous weeks, so I can have a weekly pattern. The key thing is, this is looking at what is normal, what is usually happening on the network, and then if there's a deviation from that, as we'll explore later, we can drill down into it. So let's see how far we can go with these baseline type views. One of the things I can do here is I can drill down into this data. So for example, I can select HTTP and I can go to another dashboard which I've linked to this one. So Apex uses the idea of linkages, which are just text fields which define which dashboards are grouped together. So I've used that link and I've applied a filter. This is the filter at the top. It's now filtering on HTTP only. So now I'm seeing the baseline data just for this one application component. We were seeing it on an icon. Now I'm seeing it over time. So again, I'm comparing what is happening with the current time period that I'm looking at. That could be the last hour, it could be a particular day, or a few days, or a week, or more, with the previous time periods that based on how I've set the baseline. You can see here, hovering over this time period, the actual metric is 110 milliseconds of server response time. The baseline is 134. So we're actually doing slightly better at the time 206, as you saw there. But we can go down deeper than this. So we can go into looking at the individual servers and looking at the individual conversation statistics. Also, we can then look at the baseline for those particular components. So what I'm going to do here is I'm just getting the IP address I need to filter on. So I'm going to put a particular server IP address that I'm interested in. And this is something that communicates fairly regularly on our network here. So we should see some baseline data to compare this again. So this is a filter that I put into the top of this dashboard, and I'm just going to apply that filter now. So what it's done now, it's still got the HTTP filter, now it's got an IP filter as well. But you can see here, my metric is actually exceeding baseline for this particular server. So this is what I'm showing is how we can go down to looking at baseline data all the way down to individual servers and individual conversation information. Okay, let's go back to the questions. So that's looking at what are the normal levels of response time. That's the baseline information. We're showing that in aggregate, also showing it by individual application components that comprise the service that we're looking at the delivery of, and also looking at those by server and by conversation. So let's see when and where do these deviations occur. In order to do that, we're really doing the same kind of workflow as you've already seen, but we're maybe focusing in on when those traffic lights go yellow or red. And I'll talk a bit first about how those sensitivities can be set. So here, within the configuration element of this Observer Apex tool, we have a whole area where we are setting marginal and critical percentage values. So what that means is that generally for my response time fields here, if the value that I'm looking at exceeds the baseline by more than 60%, then I see that as a yellow marginal condition. If it exceeds by more than 120%, then I see it as a critical condition, and this also affects the alerting, which I'll talk about later. If we just go into this area here, we can see that I can actually add additional custom configurations of this. So what I mean by that is maybe I have some particular services which are particularly critical and where I want to be much more sensitive in terms of how we track deviation from the baseline. So what I can do is I can change those percentages, reduce them to whatever values I like, and then I can define a filter. Maybe that is an address filter or a subnet range, which is fairly easy to define here. I just say what I want the starting and ending addresses of my range to be. So I can say for this entire 10 network, I want to consider all those services as particularly critical, and then when I run a dashboard that's looking at servers in that range, it will apply this more sensitive condition. Okay, so we've already looked a bit about drilling down into the server and client. We were exploring this particular report here where we drilled down and we were seeing statistics based on the conversations. So this is what we mean about seeing where do those deviations occur. We're seeing which particular servers, which particular clients. We can group this into filtered subnet based information. So for example, we could have our icons displaying when a particular site has an issue, whether that's defined by data source, which would be the probe that's feeding the data, or by subnet, or possibly by VLAN tag. And so there's a number of ways in which we can do this kind of reporting. And another thing we can do here is to go down to a transactional level. So for HTTP, this is something where we can run this additional dashboard report called Application Transaction Performance, and this is going to look at the individual request and response codes. So we're not just looking generically at how the application is communicating across the board. We're able to break that out into request and response types, as you see here. We can see that the GET request is actually having the longest response time. We can see which requests and responses are most frequent. In this case, happily we're getting mainly 200 OK messages. We do also see some 404s. So we can go down to looking at the level of what's my usual response time for 404 response codes coming back over the network, and look at that from a baseline perspective as well, and understand the deviation at that level. How does it affect different request and response codes? Here we're looking at the pair, so we're looking at the server and client again, the request code, the response code, and which ones have the longest response times. What we're going to be doing later is drilling into the packets that represent this in order to do our actual problem resolution on this. The last thing on this particular report, we also have data at the level of individual URL codes to particular web servers, and we can also add into this information on the browser type or the browser version being used. So there's a whole load of intelligence that we can get about how that application is working over the network, and also the details within those application communications. Okay, so let's go back to my questions here. So that's looking at where and when do the deviations occur? How can I get notified automatically? So there's a couple of aspects to this. What I'm going to start with is looking into the observer software system itself. So we were looking earlier at this view here, which was looking at packets that have been captured, possibly saved and stored, maybe processed and data mined off a Gigastore appliance. We can talk about all those options later, but basically this is packet data that I was looking at from a micro level, understanding the details of a particular set of communications with some application servers. What we can also set up on our observer probe using this console interface are triggers and alerts. So this would be one way of getting automated notifications. Within the set of available alarms here, there are a number of alarm types that can look for very low layer conditions like frame errors, like levels of utilization, like microbursts on the network. We can also match against filters. So maybe you want to look for a particular pattern of data on the network and receive an alarm. From an application perspective, we have a lot of capability here, again, with looking at the transactions within the application communications. So here we can see for HTTP, which is what we're looking at on the web view, we can see that we have the ability to receive a notification if there are any errors, if there are a certain number of requests or a certain number of response codes of various types. And this really gives a good idea of the scope of the types of transaction that are supported with Observer, as well as looking at the response time itself. The same thing applies to SQL, TDS SQL, which is SQL server traffic. I'll talk about that a bit more later on with some of the analytics. But again, we can look at the number of errors and look at the different types of message being returned by a database server. And also, perhaps a more mundane example, DNS. Everyone has DNS on their network. It's very critical for the running of many applications. So this allows you to track if there are DNS errors, if DNS responses exceed a certain response time, and also if there are DNS response codes which may be not optimal in terms of the effective running of your applications. So what you can do with this is you can receive a notification, you can receive a trap to another management system, you can send an email, you can also do automated functions like starting packet capture based on seeing a particular type of event on the network. Okay, so that's again the fairly granular kind of micro level of alerting that you can do. The other area where we have this capability is within Apex itself, where you can create things called alarm schedules, and an alarm will basically pick up the thresholds that you have defined that you want to look at, which can be compared to baseline. So let's go back and have a look at that. All these thresholds, either absolute performance thresholds, which are looking at millisecond response times or deviations for voice in terms of mean opinion score, or the percentage thresholds that I was talking about earlier. So these marginal or critical deviations. And I believe the screen is maybe a bit slow to catch up here, so let's just take a pause. And you just, I think you're possibly still on a screen which is looking at the ladder diagram. So, what can you see at the moment, Carlos? We got a little, okay, it's caught up now, thanks. Yeah. Perfect, so yeah, this is where I am now. This is the alerting within the Apex system. And one of the things about Apex is it has the ability to aggregate data from many data sources. So with the Observer alerting, you're setting up individual event types that you want to track at individual specific points on the network. That can be very granular, very detailed, as I said, and allow you to look at things from a very fine-grained level. With this, you can look at aggregate data, and you can compare that with baseline in order to get that automated notification from these deviations. What you get out of that, just to show you the kind of information you get on one of these alerts. This has come from Observer Apex. This one has actually told me that my traffic rate has exceeded the baseline value. So that's generated a critical alert here. And again, from what I'm seeing here, okay, that's just caught up. So that's what I just talked about. That's the alert that you get out of Observer Apex via email. Okay, so what I'm going to talk about next is what do we do to actually understand the root cause of the deviations. We're looking at application performance in terms of delivery over the network and also in terms of the transactions within the application that we're seeing from the packets and that we're tracking from the statistics that we generate. So when we see something go yellow or red, we are drilling down. We can go to a certain level of data. We can go down and to looking at the transaction codes themselves. But we're not yet getting all the analytics that are really going to help us determine the root cause of issues in here. So before I go into the more analytical views, I will just finish off in the reporting with one final way of looking at this, And this is just a nice simple dashboard that I've created in Apex, and it's just comparing two things. So this is just comparing network round trip over time, and that's comparing to the baseline. So the blue line is the actual, the green line is the baseline. The green zone is up to 60%. Above baseline, the yellow zone is up to 120%. And I'm comparing that with the traffic rates, so the bit rate. How much traffic have I got on the network? That's one of the initial types of correlation I want to do in order to understand, are my performance problems caused by spikes in terms of network traffic? And this is something that's very simple to do in Observer Apex. Before I kind of leave Apex alone, I'll just show you how this is a tool where it's easy to create your own dashboards. It's designed so that you can build your own dashboard views. You just put widgets in, so a widget will just be an element. There are a number of system widgets that you can use. Top web response codes will build you this donut view looking at your response codes for all your web traffic. Maybe I want to add into that information like we had just earlier looking at the traffic rate. So it's very drag and drop. You just add these widgets into this dashboard, you save it, it will then be available for you to view. You can promote it, and then your colleagues who are using the same Apex system can also see the same dashboard view as this. Okay, so correlation, that's one way in which you can do root cause analysis, because it could be that the problem is a simple one. You've just got too much traffic going on the network for that time period. That caused everything to get congested. It caused your network round trip times to increase, which also affected your server and client response times, which affected the end users, the actual application users themselves. What I want to show as well here is that when I'm in that kind of report, so here we are looking at the same kind of view you were looking at earlier, where we were in Apex and we were looking at a particular conversation. But we're seeing here that this conversation has a client response time of 3 seconds. So that's caused a deviation in our baseline view. What do we do now? If we have a Gigastore appliance, we can click on this thing called Gigastore reports. And what this does is this provides information from the web interface into our Observer console, which is appearing on your screen hopefully soon. And the Observer console is going to data mine the packets from a Gigastore. So the Gigastore is an appliance that is capturing to disk all those same packets that have been used to generate those statistics. And it's selected the time frame from 11 till 11:30 up here. It's done that automatically based on that report. So that means when I click this Analyze button, it's going to give me the right time period, because I was looking at a half-hour period within my report. You don't want to do this with data that's from 3 weeks ago, and you don't want to do this with huge intervals of data, because we're now going to a packet level. We're talking about terabytes of information to search through. Therefore, we're going to do this when we've drilled in and we're looking at a particular time period. But what this has done is this has created a filter looking for that one conversation. So the idea is we're going to go and get the packets for that one interaction between those clients and that client and that server. There's a web client and a web server. And here is our response time, 3 seconds. So that's the same as what we see in the web report. But now this has done a post-analysis processing of that data. It's mined out the packets. It's processed them. We've got the same response time, but now we've got the ability to look at that in detail. Going back to this micro level of view, we've got the SYN, the SYNAC, the ACK. We can see how quickly the network delivered that interaction. So we're getting an understanding. Doesn't look like the network is the root cause. Looks like it's a slow client. When is that happening? Well, we can see here the client acknowledges the data that the server sends, but then there's a gap of 4.4 seconds before it sends the next GET request. Why does that gap occur? That could be that's an automated application processing thing happening on the application. It could be that is actually end user activity or the end user is just doing something else, typing something in. This is where you need to know the application, and obviously you need to do some profiling and get the application and possibly the end user involved in some cases. But this is giving you information to see clearly what application requests, what transactions are being affected, where are those delays occurring. So when I went and got that data, you saw that I did it very automatically from the web reporting. That's designed to save time. That's the integration we have between these two interfaces for our products. I can do exactly the same thing a little bit more reactively by going in and going to a particular time. So there's a little bit more manual input here, but not every customer has Observer Apex. And for troubleshooting, you can go back and use this Gigastore interface within Observer in order to just find a particular time period. I could go back quite a few days on this Gigastore because it's not receiving much traffic. But I can do some reporting on this, understand who are the top talkers, and then I can do some very quick filtering, perhaps based on something that I've selected in one of these tables, in order to take me into this expert analysis interface where I do my root cause analysis. So let's look at that in a couple of ways. I'm going to talk about layer 4 troubleshooting. So what I mean by that is we've got some data here where we had a report that this was a slow connection, but similar to what we've already looked at in terms of the reporting, we can see that the network delay is actually looking okay, is what we expect. Everything's green from that perspective. But in our expert, we have this comment saying low window size. So what the expert is a series of thresholds which operate in a way that's organized according to the OSI model. So on the transport tab, we have some thresholds that are looking at issues within TCP itself and a couple of UDP-related thresholds. And you can see here that we are looking for TCP window size, also looking for things like retransmissions. By the way, what it means by a UDP retransmission is basically it's going to look at the data request and response, like, for example, DNS request or a NetBIOS name service request. So that might look a bit strange to some people, but that it's looking actually at the application layer, but it calls that a UDP retransmission. So this is telling us that there's some low window sizes. And one of the types of view that we can do on this is called time interval analysis. What I like about this is that I can get a couple of different ways of looking at this data. I can view this on a graph, and I can choose two different parameters. So these are these metrics that we're seeing in this area called TCP events. I can, this can look at response times like we were looking at earlier, but this can also look at window size and the level of retransmissions. These things are often correlated. The server may be starting to retransmit a lot of packets, possibly because the client cannot accept that much data that the server is trying to send. And then you'll see a correlation between the window size, which is up here in green. If this is dropping, maybe there are retransmissions occurring after those drops. So that's one of the analytical functions that we can use in order to understand, is TCP working correctly to deliver this application over the network? And that's all part of the expert analysis, which we saw up here, and we saw in our data here. We were seeing all these TCP slow responses. But this is what can tell me at quite a detailed level about issues within the delivery of the applications. What we also have here is a view of layers 5 to 7. So SQL traffic is database request and response traffic. We see select statements. We see response codes coming back. We hope to see a lot of done responses. That's good. If we get error notifications, this indicates an issue within the application as we're seeing it from a network perspective. Because we're capturing all this traffic and we've got the packets, we can get an index of all those request and response interactions. We can export this data as PCAP, so we can share this with our colleagues in the application team or possibly the application vendor. We can also export this list. So I can now share this list to say, we see all these errors within the interactions. Here you are, here's a CSV file with all those in. I closed that too early. What I meant to go into here is the fact that I can go in to look at these within the decode view. So what I have now is a 3-pane decode, but I've gone immediately to packet number 135, and you can see down here that we can see the exact select statement that's generated that, and in the response, which in this case was the very next packet, we can see it says invalid column name. So perhaps I'm looking at this because I am in charge of debugging the application from a network perspective, and I'm going to use this information to maybe write a report to say what I think is wrong and why these deviations are occurring and why end user performance is impacted. Or perhaps I'm just going to share this information with colleagues or with third parties. Okay, what I'm going to do now is go back to my list of questions, which I'm getting fairly near the end of. So my final question is more looking at the future. How will my applications, new deployments, how may they impact the network? So I'm really going to be using all the same views that I've used so far, but maybe I'm going to have a pilot network and I'm going to monitor that and set up my dashboards, use Capture to look at how that works, how those, what kind of levels of traffic do my applications create. So let's go and explore a few of those ideas. One type of dashboard that I can run is looking at network activity, and this is looking at the total activity over time. You saw this same graph, this same widget in my correlation report where I was comparing the network response time with the traffic rate. Here I'm looking at how that impact breaks down, what IP stations are creating that traffic, what applications are creating that traffic, and I can do all that interactive filtering that you saw earlier so that I can understand what does HTTP look like over time, see that as a baseline. And here we can see in terms of HTTP, we've actually got quite a significant deviation from baseline here. So we can use all this from a planning perspective. Back in the Observer console, we also have a tool here where what we can do here is we can take a particular conversation. So let's look at this conversation at the top here. It's from an application here that we haven't yet defined. So this is a new application using port 59533. I'm going to want to go and define this. I'm going to go into my list of application definitions, and I'm going to add this as a custom application so that I recognize that port and can then do reporting specifically on that component. But what I'm going to do here is run a tool called what if analysis. This can be used to say, what if we increase the number of users who are doing this function at any one time? So this line on this graph is telling me about what level of utilization I would have at different levels of bandwidth. Maybe I've got a site which has a 10 meg link out to it, but I'm going to have 10 users all doing this same function every time they log on in the morning. It's going to start up this application and create this traffic. So I can look at how that would impact the bandwidth in the future. We're looking at about a 20% utilization impact on that. Other things that I can do here from a planning perspective, I've got a list of all my conversations here. One of the things I can do is go and export that. So I can save that in a comma delimited format with all the information about the number of packets and bytes and the response times we're seeing. And that means I could then load that up in something like Excel, and I could do some processing and some calculations on that. So that's always a good function to have. If we get over to the Apex reporting system itself, what we have here is a RESTful API. So our customers have the ability to pull data out of the Apex reporting system and move that into any third-party system they want to use that. So that could be for billing purposes, or that could be for capacity planning purposes. And you can see some of the potential integrations on here. So this is a system very much set up to support orchestration initiatives that you may be deploying, and that certainly includes using this from a network impact planning perspective. Okay, so I've run through all the scenarios there that I wanted to explore, looking at those 6 questions, which I see as the key questions to ask in terms of getting visibility and managing your applications on the network. How do we get this data? I mentioned this is coming from packet data. So our customers deploy taps and span ports. Sometimes they aggregate those data fields. We have an aggregation switch there called the matrix. There are other aggregation switches available. That doesn't matter in terms of what data comes into the Gigastore. It supports up to 12 capture ports on it, so it can capture a lot of links, a lot of inputs going into it. We have other types of probes that will generate all the statistics that you saw in the Apex solution. So you have those 2 things, the packet data being stored on a Gigastore, and also the statistics going up to the Apex platform, where the statistical data is all centralized. Because it's statistical, it's not huge volumes of information, so it can be sent to one place in order to get aggregated views of the applications as they're delivered over the network at various points on the network. The packet data is kept out on the appliance itself because, as I mentioned earlier, this can be terabytes, hundreds of terabytes. We can do up to more than a petabyte of capture data on a single Gigastore. So what we saw there were 2 aspects of the user interface, the web reporting and the observer console. We also have a management platform called OMS, which takes care of all your user authentication and policies and such like, as well as doing various data synchronization functions. These are the types of Gigastores that we have from the packet capture and storage to disk perspective. We have a portable system which you can use as a very high performance kind of laptop with 4 or 8 terabytes and with a high performance capture card built into it. And then we have a number of rack mount systems ranging from 4 terabytes up to the 1.1 petabyte level. And these can be scaled so that you can add storage without having to de-rack the system and do any kind of business affecting upgrade. So it's a very easy upgrade process to do this. So where do you deploy these? Very good question, and we can certainly discuss this in more detail. This is where we really get down to the details of how does your network look, where do your applications traverse the network, where are the key pinch points. Often it's a case of looking between core infrastructure and maybe server switches or blade clusters or whatever you might have within the data center. Obviously this is simplified, you're going to have resilient links in here. I mentioned the Gigastore has 12 capture ports that you can put on it, so you can feed up to 6 links into a single Gigastore. You might look at either side of some infrastructure like a firewall. That could help you look at what is the latency going from one part to the other. If you have a fairly multi-tiered, layered environment with lots of firewalls, lots of load balancers and various different infrastructure components, then you might need to look at the same traffic in different points as it traverses your network. You may be just looking at traffic coming off your wide area network on the assumption that that is where most of the performance problems are likely to be occurring. You can look at the distribution layer, you can look at the edge, your access switches. So there are many options, and we can certainly help with that discussion. So this is my last slide before we turn this over to questions. This presents our overall solution architecture from a very high level. You saw on the previous slide we've got packet data coming in via taps, possibly via the matrix aggregation platform, and that is then going into Gigastores and probes. So these are the things that are receiving that data. The observer analyzer is providing one of the views in which you can access that. The minimum configuration really is just a Gigastore, and it's got Observer built into it, but the Observer Apex is really, I guess, a lot of what I've been talking about this morning. So Observer Apex can be software or can be an appliance. It receives statistics from your Observer Gigastores and your Observer probes based on the packet data, and it presents those dashboard views. So I hope that is making sense to everyone. What I'll do now is to hand back to Carlos so that he can deal with questions.